السلام عليكم ورحمة الله وبركاته. يعطيكم العافية وبنرحب فيكم طلاب سنة أولى مقرر الرياضة المالية أو Mathematics of Finance. Our text or book will be this Mathematics of Finance with the author Robert Brown, Stevie Cope and Peter Zima. The content of this course will be عبارة عن 3 chapters. Chapter 1, simple interest and simple discount, and chapter 2, compound interest, and chapter 3, simple annuities. If we have time, we will transfer to chapter 5, general and other annuities. Here in the contents of this of chapter 1, simple interest and simple interest and simple discount. Section 1, we will have accumulated value at simple interest and discounted value at simple interest, equations of value, partial payments, and simple discount at a discount rate. Section 1.6 will be summary and exercises. Chapter 2, we will have compound interest, but when we reach it, we will say which sections we will have and which sections we will omit, and also here simple annuities. When we reach it, we will say which we will take it and which sections we will omit. Let's begin with chapter 1, simple interest and simple discount. You can read learning objects by yourself. And now we will begin with section 1.1, accumulated value at simple interest. In any financial transaction, there are two parties involved as investor, investor المستثمر who is lending money to someone اللي يعني ممكن يسلف money to someone, and debitor المدين أو المستلف أو الدائن who is borrowing money from the investor اللي بيسلف الفلوس من المستثمر. The debitor must pay back the money originally borrowed and also the rent for features for the use of money اللي هي interest. يعني هيرجع للمستثمر المبلغ اللي أخده، سواء مثلا نعتقد إنه 1000 دينار وفوقهم الفائدة بتبعتهم مثلا نقول 100 دينار مثلا. From the investor point of view, interest is income from invested capital. طبعا من وجهة نظر المستثمر إنه هذا ربحه من وراء تشغيل الفلوس، أو بالأحرى مقابل إنه سلف هذا المبلغ لشخص ما وأخذ عليه فوائد. The capital originally invested in an interest intersection is called principal. رأس المال principal. The sum of a principal and interest due is called amount, which is S. Amount, which is S. Here S equal B plus I. B plus I. B principal, I interest. This is called S, amount, accumulated value. Any interest intersection can be described by rate of interest. I equal B multiplied by R by T. Rate of interest, which is R, and percent with percent. T time with what? Time in years. In years. Time in years. Suppose which is the ratio of the interest earned in one time until on the capital principal. But if you have the time in days, divide by 365. If the year is or exact, but if it is ordinary, you must divide by 360. If the year for the February month, it is 28, always 28 days, except when it is leap year. Leap year means sana kabisa, which is a number then when you divide it by 4, you will have an integer, no decimal number. In early times, the principal length here, length and the interest paid might be takeable goods. Now I will leave this part here. How we can describe this formula? We shall use the following notation: B equal principal on the amount borrowed or the amount invested. Then B has 3 names: the amount borrowed, the amount invested, and the principal. I, simple interest, is the amount, the accumulated value of B, the future value of B, or maturity value of B. That is S equal B plus I. That is S equal B plus I. R, annual rate of simple interest, T time in years. T time in years. Simple interest is calculated by the mean of this formula. I equal BRT, where B is the principal, R is the rate, interest rate, T time in years. Time in years. From the definition of the amount S, we will have substitute instead of I by substitute by here I will rewrite it again. Instead of I put BRT, take B as a common factor, then you will have B S equal B, open a bracket, 1 plus RT. Here, the quantity 1 plus RT, the factor 1 plus RT in formula 2, which is this, is called accumulation factor at a simple interest rate R. And the process of calculating S from B by formula 2 is called accumulation at a simple interest rate R. Here, we can display this timeline by putting S and B. B is now the principal. After some years, T, we will have S, which is this. Notice the arrow. Now, till after certain time. Here, now, accumulated at R over T years, S equal B, open bracket 1 plus RT. Substitute instead of I, BRT. Notice here, the time must be in years. When the time is given in month, we will divide it by 12. When the time is given in days, there are 2 different varieties of simple interest in use. Exact interest, you must divide by 365. But here, days, leap year or not. Ordinary interest, T, number of days divided by 360, the year is taken as 360. What is leap? What is the meaning of leap? Sana kabisa. Sana kabisa, notice here 2020 divided by 4, 505, which is integer. 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 Which is integer, leap year. But if you divide also this year, our year 2024 is a leap year, Sana Kabisa, which means that February is 29 days. But notice next year, inshallah, 2025, there is a remainder here, remainder. الباقي. Simple year, we call it simple year, سنة بسيطة, and February will be 28. Calculation, read it. You can read here. We will have to see example number 1. Example number 1, page 4. A loan of $15,000 is taken out. If a simple random interest rate is of the loan يعني قرض 7%, how much interest is due and what is the amount repaid if? The amount means S. Amount means S. Amount means S. And interest means I. Amount S. And here I. Interest I. The loan is due in 7 months. Now we will see here I equal BRT 15,000 multiplied by 7 over 100 multiplied by 7 over 12 since it is 7 months, which is $612.5. S, the accumulated value, which is B plus I, 15,000 plus 612.5, which is 15,600.5. Here, the loan was taken out on April 7 and is due in 7 months. Before we solve, we must notice that in this material, you must know the order of the month and how many days in each month. This is why I write it here. I write it here. Here. Notice January 31 days. February maybe 28, maybe 29. This is leap, this is exact year. March 31, April 30, May 31, June 30, July 31, August 31, September 30, October 31, November 30, December 31. December 31. The order is very, very important. Order is very important. Important. You must memorize them. Here, from 7 April till 7 months. In order to calculate here, you have February, April, you have March, May, June, July, August, September, October, November. 7 months. In order to calculate, this is 1. The open space is 1, which is read 1, 2, 3, 4, 5, 6, 7. C, 7 October till 7 November. 7 November, 7 June. 7 June, 7 July. 7 July, 7 August. 7 August, 7 September. 7 September, 7 October. 7 October, 7 November. Write the days of each month, which is 30, 31, 30, 31, 31, September 30 days, October 31, November 30. Number of days you will have. You will begin after 7 days of April. This is why we write 30 minus 7 plus 31 plus 30 plus 31 plus 31 plus 30 plus 31 plus 7. 7 of November, which is 214 days. Pay attention in addition and in calculation, since any different number you will have different results. I equal B multiplied by R multiplied by T. You will have here, since the time is the days, this is why we will divide by 365 until he said to me ordinary year. You will divide by 360. And I interest $615.6164 dollar is accumulated. B plus I, you will have this number. Returning back to example number 2, determine the exact and ordinary simple interest on a 90 days loan of $8,000 and at 8.5 interest rate percent. Now we will see exact and ordinary simple interest. Here you will have example number 2, page 5, R equal 8.5% interest rate, B principal 8,000, T 90 days. Exact interest, I equal B multiplied by RT. Exact means divide by 365. You will have this. Ordinary interest, which means divide by 360. Notice that always ordinary interest, always ordinary interest is greater than exact interest. Ordinary interest is greater than exact interest, which increased revenue to the lender. Here, suppose you calculate R equal 3.56. With respect to R, you must multiply by 100. Then you will have 356%. This is for the interest rate. Suppose you calculate T, in which ends the time, and you have a fraction. If you want it as month, multiply it by 12. Then you will have the month. If you want it to be as days, then multiply T by 365, and this is, you can find it by days. Return back to the examples or your book. You will have here 3 is easy, example number 4 is easy. Here look at example number 5. A deposit of 1,500 is made into a fund on March 18. The fund earns simple interest at 5%. On August 5, the interest rate changes to 4.5%. How much is in the fund on October 23. First of all, you have two interest rates. You have two different number of days. Then you will calculate it from 18 March till 5th of August, and then calculate another time from 5th August to October 23. You must calculate the months and the days, and then calculate the interest for the first period and interest for the second period, and then add it to the principal, the original principal, which is 1,500. Let's see it. Example number 5, page 5. B, you will have here B equal 1,500 from 18 March till 5 August. You will have April, May, June, July. Then calculate, put the days on each month, and then calculate. Here he doesn't give you number of months, but he give you the beginning and the end of this period from 18 March till 5 August. Till 5 of August. T1, number of days. You will begin 31 minus 18, since you will begin from 19th, plus 30, plus 31 of May, 30 of June, 31 of July, and 5 days from August. This is the first time, which is 140 days. T2, you will begin from 5 August till 23 of October. Inside there is September. Then you will write here August 31, subtracting from 5, plus 30 days of September, plus 23 of October, 23 days. You will have 79 days. Here S equal B plus I1 plus I2. B plus B plus R1 multiplied by R1 T1 plus B multiplied by R2 T2. You will have here the amount or accumulated value 1,543.38. Here, let's return back to examples here. With respect to demand loan, I will delete it until we will reach it. In next sections we will take it, but now we will discuss another material which is called invoice cash discount. Here, to encourage promote payments of invoices, Kimbiala, many manufacturers and wholesalers offer cash discounts for payments in advance of the final due date. The following typical credit terms may be printed on sales invoices. If you see like two fraction, 2/10, comma, n over 30, which means that you have discount 2% if you pay within 10 days. Here 2/10 and comma n over 30, which means you have discount 2% if you pay before 10 days. Otherwise you will pay the amount during 30 days. goods bill on his basis are subject to a cash discount 2% if paid within 10 days, from the date of the invoice. Otherwise, the full amount must be paid not later than 30 days from the date of the invoice. Payments must made after 30 days are subject to interest changes. Here, merchants want to pay their invoice early in order to receive the cash discount, but may not have the cash to do so. They may consider borrowing the required money. The loan would be taken out as late as possible on the last day in which they can receive the cash discount, and it would be paid back on the day the original invoice is due. The merchant would consider borrowing the money as long as the interest on the loan doesn't exceed the cash discount received. Example number 7. Here, the merchant receives an invoice for the motor boat for $20,000 with a term 4/3 N/100, 4/30, which means that you have a discount 4% during 30 days if you pay before 30 days. Otherwise, you will pay all the amount during 100 days. What is the highest simple interest rate at which he can offer to borrow money in order to take advantage of the discount? Let's solve it. Here I return here. I solve another question, but let's read it here. Suppose the merchant will take advantage of the cash discount of 4% of the $20,000, which is what? 800. Then you will have the proceed will be 20,000 minus 800, which is 19,200, and he must pay the bill within 30 days from the date of the invoice. He needs to borrow 19,200. He would borrow this money on 30 days and repay it on day of 100. The day, then you will have to cancel or subtract 100 minus 30 days. You will have 70 days. You will have 70 days due, resulting in 70 days. The interest he should be willing to pay on borrowed money should not exceed the cash discount 800. We have B equal 19,200, I equal 800, and T equal 70/365 days. I, which is the interest, the discount, we will have to calculate R, which is the highest simple interest rate, I over BT, which is 800 divided by 19,200 multiplied by 70/365, which is what? You will have it here 0.2 2173 multiplied by 100, you will have 21.73%. You must put this sign percent. The highest simple interest rate at which the merchant can offer to borrow money is 21.73%. This is a break between rate. If he can borrow money, say at the rate of 5%, he should do so. He would borrow 19,200 for 70 days at 15%. Maturity value of the loan will be what? 19,200 multiplied by 1 plus 0.15 multiplied by 70 over 365, it will be 19,752.33. Thus, his saving would be what? Saving would be 20,000 minus 19,752.33, which is 240.67. Thank you very much, and next time, or I can give you the homework here. Homework for this section, page 7 will be number 1, 2, 3, 4, 6, 7, 8, 9, 10, and after that 15, 16, 17. 15, 16, 17. We will solve some questions about this material next video, inshallah. Thank you for your listening, and see you next video. Thanks.